Alright, and welcome to Unit 3, Lesson 7 on friction force. This video we will go over example number 3, which is the last of the examples in the friction force topic. And this problem has an applied force pushing down at an angle. Truth be said, this is a little bit of a longer problem, so just prepare for a little bit of a longer, more complicated solve. That said, really there's nothing in here that we haven't truly done before. Forces at angles, we should know hopefully by now that whenever we have an angled force, we're going to break it up into its x and y components using trigonometry. And then we're just going to solve it just like everything else. We're going to find the F net in the x direction, F net in the y direction, and then we're going to use the sum of all forces F net formulas for both as well. Using those formulas, we're going to find out our missing values, and typically those missing values are what we are looking for. Alright, so to begin this, first step that I want to do here is I want to, write and draw all my forces on my diagram. So I have already drawn on force number 1, and I've got the angle, and I've got the little dotted lines for the components, but I haven't written the components on yet. So what we have is we have a block, and the question tells us it's moving to the right already. So this block is sliding along the floor. There is a force pushing on it with 190 newtons, and there is a coefficient of kinetic friction of 0.93. which is quite a high value. I think you're going to find that, this value is saying that almost everything in terms of weight or normal force on this object is going to be friction. So let's draw on some forces here. I'm going to lighten this up because I was using green, which is kind of a light color. And we can say that pulling downwards on this, we have the force of gravity. Fg is down, and to complement that one, we have the upward force normal. What else we got going on here? We've got moving against the motion, so motion is going to the right, meaning that our force of friction has got to be to the left here. So force of friction to the left. Alright. The only thing really we have left then is to break this angled force up into force 1y and force 1x. Okay, these are the forces. We can maybe draw some little arrows. This is down and to the right, so this F1y is downward. This one, F1x, is rightward. Okay. Well, I think for simplicity and just to get it out of the way, let's solve F1y and F1x first, why don't we? So, let's choose a new color, and, I don't know which one to solve first here. Let's do F1y. So F1y first. And we have F1y is opposite side, so it's going to be a sine value. So we can say that is sine of 24 is equal to opposite F1y over hypotenuse, which is our force, which is 190 newtons. So F1y works out to 77.28 newtons. And we can also give that the direction because it's going down. So it is down. Okay. F1x, almost the same situation, but it's going to be cos 24 is equal to F1x over 190 newtons. So F1x works out to 173.57 newtons, and that's, well, to the right, so it's positive. Okay. Well, let's do a little bit of solving here. Ultimately, we're going to want to find this force of friction. I don't think I said at the beginning if you don't have the sheet in front of you, but ultimately what we're solving for is the acceleration of this block. Okay. So, to find force of friction, we're going to need normal force first. So let's solve the y direction first, and then we can get into the x direction and isolate for friction. Cool. So in the y direction, maybe do solve y. Solve y. Well, this object isn't jumping and it's not sinking into the floor, so we can say that F net y, well, which is equal to mass times acceleration. Since it's not jumping or sinking into the sheet, O is 0, or A is 0, which means F net y is equal to 0. Well, that makes things easy, because then we have F net y is equal to the sum of all the forces in the y direction. So it's equal to the normal force plus the force of gravity plus F1y, right? F1y here, which we just solved for. Okay. So now we end up with putting some numbers in. 0 is equal to normal force plus 18.5 kilos times negative 9.81 meters per second squared. Notice now that this negative 9.81 meters squared is going to make this value negative. Force of gravity is down, so that checks out, right? And plus our F1y value, which is 77.28 newtons down. Well, down again in our negative direction. Let's switch this value to a negative value because it's downward. So actually we're going to subtract 77.28 newtons. Alright, when we plug this in and solve for it, I get a value of 258.765 newtons. Okay. Well, I think we're getting pretty close to getting there. Let's jump to a new color. Let's move on to X. Solve X. Alright, now we want to find this friction value. Well, force of friction is just equal to the coefficient of friction times the normal force. So, let's do, well, yeah, let's do that. If we started with our normal F net formula, we're looking for acceleration. So maybe we'll do that first. We can say F net x is equal to mass times acceleration. And ultimately, we want acceleration. So we're going to have acceleration is equal to F net x over mass. But we don't know F net x yet. So that's why I started on the other way. So we can say that maybe just beside it here in magenta, F net x is equal to the sum of all of our forces. So F net x is equal to force of friction plus F1x. I think those are the only two forces we've got going on in this x direction. Let me look at my cheat sheet here. Yes, no, those are the only two we've got going on. Force of friction, F1x. And they're moving in opposite directions. Okay. So I think we can more or less solve for that because we already solved for F1x here. So F net in the x direction is equal to force of friction, which is this coefficient of friction 0.93 times normal force 258.765 newtons. And that value is going to the left here. So force of friction, actually, let me make a little space here. It's going to be a negative value. Here's a little equal sign. Alright, that looks a little ugly, but okay. And then we are going to add to this F1x value, which is to the right, which is 173.57 newtons. Okay. And what we end up getting is we get an F net x value equal to negative 67.08 newtons. All right. Now, you might think to yourself right away, hold up, if we get a negative 67 net force newton, doesn't that mean force of friction is greater than the applied force here in the x direction? And the answer is yes. Yes, it is. We are allowed to have a force of friction that's greater than the applied force if this object is moving. Because now essentially what's happening is we're putting the brakes on, right? This force of friction is greater than the applied force in the direction opposite to its motion, which is going to cause it to slow down. It's an effect which is essentially putting on the brakes. So we can figure out that acceleration to the left now because we have F net x. So I'll switch back to my blue and we'll finish this thing off. We can say that, I'm going to just drop this down here where there's a little more space. That acceleration is equal to this negative 67.08 newtons divided by 18.5 kilos. So our final acceleration on this thing works out to negative 3.63 meters per second squared. Or we can say that this is equal to 3.63 meters per second squared left. And for a little bit of clarity, I might just add a little note on here. And did it say this was a car? No, we'll say the block is slowing down. Block is slowing down. Okay. That is this problem.